All right, stats, welcome to your exam number 3, video 3 here for this exam. Again, we'll explain it in the other videos when this would occur. I'll know more hopefully at the end of next week when we're coming back. So it will happen about 4 or 5 days after we get back. All right, here it is. Company with 1,452 cars found that the emission systems of 25 out of the 200 they randomly chose and tested. The sample size is not 2452. It's 200. Tested to meet pollution control guidelines. We would like to test that this is strong evidence that more than 10% of their fleet might be out of compliance. More than. Test our claim at 5% level. More than means this is the alternative hypothesis for sure. P greater than 0.1000. The null hypothesis is less than or equal to. Right tail test. For proportion, we always use Z. Alpha is 0.05. Right tail test 1.645. B hat 25 divided by 200, 0.125. Z would be P hat minus P divided by in the square root. P times 1 minus P. All that divided by N. Again, 0.25, then you get that in your calculator. Do 0.25 divided by answer. 1.18 does not fall into the rejection region. So I fail to reject HO. I say HO is good. So there's many different ways you can say. You can say no, there is not strong evidence that more than 10% out of compliance, or you can just say what the null hypothesis is, that 10% or less would truly be out of compliance. Interesting. A hair salon manager claims that on average, at least 50 people get their hair cut at their salon each weekday. Probably not right now. An analysis of the last 50 weekdays has produced a sample mean of that. With a standard deviation of that, test the manager's claim. So at least means greater than or equal to 50. It came up short. All right, it makes sense that the alternative hypothesis, what we would be testing here, is that it's less than 50. Okay. So that is a one-tail test. Negative 1.645 for one-tail. Alpha is 0.05. My test stat would be the sample mean minus the proposed mean divided by a standard deviation over square root of n. It's a negative 5.10 divided by some number. So that is in my rejection region, negative 2.71. Reject the null hypothesis and say that their claim is bad. The mean is less than 50. All right, let's keep rolling. Mr. Yak has a part-time gig as a 400-meter workout pacer. I claim that I can average 75 seconds exactly for 400 for any given workout. Sampled my last 6,400-meter repeats as a sample mean of that and a standard deviation of that. Test my claim at the 1% level of significance. So I want to be right at 75, not too fast, not too slow. That is why it's a two-tailed test, alpha 0.01. Biggest z-score for my rejection regions, that is, negative 2.576, 2.576. So it looks like I actually came up on the slow side here. 75.17, sample mean minus the proposed mean divided by the standard deviation over the square root of n. 3.19. Reject my claim. My true mean is not 75. Pacing gig over. Medicine that helps you quit smoking. That is what smoking cessation means there. Claims that at least 60% of individuals that use their medication for the prescribed 8 weeks will officially quit smoking. A random sample of 250 recent medication users found that 139 had quit smoking. Test the company's claim at alpha is 0.05. They said at least, so that is greater than or equal to 0.600. That is the null hypothesis versus the alternative hypothesis of P is less than 0.600. Left tail test. All right, alpha is 0.05. Rejection rate is going to begin at negative 1.645. P hats, it did come up on the short side. Z-score is p hat minus the proposed p divided by the proposed p, 1 minus the proposed p, divided by the sample size. Negative 0.044 divided by answer. Negative 1.42. So, uh-oh. These times, folks, never trust a cough. Negative 1.42 is not in the rejection region, so we fail to reject it. Even though they did come up short in the sample, right? We fail to reject it. It's not short enough, all right? So they still are technically allowed to state that claim. Interesting. All right. Though productive coughs, which that one was, I believe, are not a sign of the big bad virus, I believe. It's the unproductive cough. Anyway, you have a lot of time to Google things, folks. Be safe. A certain alkaline water claims to have a pH of at least 8.2. 75 randomly chosen 1 liter bottles of this alkaline water were tested. Sample mean pH of that and the sample standard deviation of that were found. Tested the company's claim at the 5% level of significance. Have at least, that's greater than or equal to. It came up short in the sample, so that makes sense that we're going to do a left-tailed test. Coming up short means it has a negative z-score, and that is what I'll have here if I do a left-tailed test. Alpha is 0.05, a single tail, negative 1.645. Is it short enough, though, to say, liar, liar, pants on fire to the company? Sample mean divided by the proposed mean, divided by standard deviation over the square root of n. Negative 0.16 divided by some number. Negative 2.27 does fall in the rejection region. We reject their claim and say that, yes, the pH is not as high as they say. Certain fast food establishment claims that customers will have to wait no more than 90 seconds for their order. That was a big deal. At McDonald's, when I was in high school, they used to have the stats on the register. A data analyst samples 250 orders for a 3-day period. A sample wait time of, too long, and a sample standard deviation of that are obtained, tests their claim. So they say no more than, less than or equal to, and you're like, well, it might be greater than. The sample mean was greater than. This is a right-tailed test. Alpha is 0.01. That is the 2.33. Z is the sample mean divided by the proposed mean, or minus the proposed mean, divided by the standard deviation over the square root of 250. 7.16 divided by some number, 6.96. So yes, that is a huge z-score. We definitely reject HO and say that it's definitely going to be more than 90 seconds. All right. And then, just a few more here. A drug needs to cure symptoms in at least 60% of its patients, of users in a clinical trial to go to market. In the last clinical trial of that many patients, that many saw their symptoms cured. Create a 95% confidence interval for the population proportion and comment on whether or not this drug will undoubtedly means the lower end of the confidence interval is still above 60%. Undoubtedly means it's definitely over, okay? P hat is that, so that's looking okay. This is the confidence interval formula. P hat plus or minus the Z star, 95% confidence interval is 1.96 times the square root of P hat, 1 minus P hat, divided by your sample size. Margin of error is 5.1%. There's your confidence interval. On the high end looks great, but folks, on the low end, it goes below 60%. So there is a chance that we will get some samples of this size that have a sample mean below 60%. So it's below 60%. We could not use the words undoubtedly. Okay? The old SAT had a mean score of that with a standard deviation of that. The new SAT, and this is true, produces a higher mean. Right now, create a 95% confidence interval for the population mean of the new SAT and comment on whether these results predict a definite improvement over the last test. Well, here's the thing, folks. You need a sample size. So let's say a sample 500 students for the last few years were taken. So add that in. So the mean score, sample mean 1,053 plus or minus 1.96. Standard deviation is 209 divided by the square root of 500. Again, you need to add that in. All right. Yes, on the low end, it is still above 1012. So yes, the new SAT results are looking better. All right, and then we are going to finish with the part 1 of this review right here in a sample of 1,257 registered voters. Speaking of voting, if you're 18 or over, hopefully you voted in the primary yesterday. 682 stated they would vote for candidate A. Mr. Yak did, Mrs. Yak did not. So wag the finger at her. Test the claim that candidate A will receive a majority of the votes in the upcoming election at both the 1% and 5% significant levels. A majority of the votes means greater than 50%. Okay? Doesn't matter how many people are in the election. If you get more than 50% of the votes, you are undoubtedly the winner. Okay, this is a right-tailed test. Yes, you do need to know the majority is bigger than 50%. I have 2 right-tailed tests. Okay, that's alpha's 0.01, alpha's 0.05. My z-score is the same no matter what. My p-hat is that, 543. So 543 is good. Is it good enough to really feel comfortable about this candidate winning? P-hat minus proposed p. You know, again, proposed P doesn't mean like that's what they're saying. In this case, they have to win a majority. So the proposed is, do they have a majority? So 0.50 divided by 1257. 043 divided by answer, that is 3.05. Doesn't matter which alpha I'm using. At both alphas 0.01 and 0.05, we are going to reject HO and say that yes, they're looking pretty good as to receiving a majority of the votes. And lastly, a part must be exactly 10 centimeters in diameter so that a machine can work to maximize efficiency. Random sample of 130 of these found a sample mean diameter of that. With a standard deviation of that. Test the claim that the mean diameter is exactly 10 and alpha is 0.05. Exactly is that. So this is a two-tailed test. Two-tailed alpha is 0.05. That's a 95% confidence interval number. It is off, but is it off by enough? Sample mean divided by proposed mean divided by the standard deviation over square root of, 130. I bet you I made a boo-boo. We're going to quickly do this here because that is 130. So 0.18 divided by 100, square root of 130. 0.08 divided by number is this. Does change my answer. Again, I'm still going to reject it, but it is not 2.43. It is 5.07. Okay, I am wrong, so I would lose some points there. My judgment there doesn't change at all, but yes, you got to have that right z-score. All right, because it would fail. If I made that mistake, I would fail to reject it if it's an alpha is 0.01. Okay, I would say it's all good. Bad, bad, bad. 5.07, I reject HO, and I say that the mean is not 10. They need to recalibrate something. Folks, need to see those views up, folks, all right? SLU is not canceled. You guys know that, right? SLU is on e-learning, still learning, okay? So we need to stay current with that stats knowledge. I'll give you one more video here with your test review, and I'll tell you a few more things you can do for your project soon, and we'll see later next week if we're coming back or if we're staying out longer. Then I'll give you guys some more detail. All right, there's a chance you might have to learn something new via video. All right, calculus is having to do that, but SLU is not out of session. SLU's in session, folks, so we got to get at it. Okay, we need to see those views up. Okay, you guys are the college students here. All right, Yak Math Videos signing out.